subscribe my channel for JEE and NEET.
Hello students, good morning all of you. Today in our video I want to explain Newton's laws of motion by the Atwood's mission. So now we are finding the acceleration of the system and the tension forces acting on a string. So coming to the Atwood's mission, it was a device which can having two unequal masses will be suspended by a string. So here the pulley contains the massless or frictionless pulley. By this Atwood mission, we have to find the acceleration of the entire system and the tension acts on the strings. So this is the basic classroom demonstration by an Atwood's mission. This is the classical mechanics to find easily the acceleration of the system. Here the case it is the weight m1 is greater than m2. m1 is greater than m2. So this is the main case in the Atwood's mission. So now we have to find what is the acceleration of the system and the tension acts on the string. So here the acceleration of the m1 body should be in downwards direction and the acceleration of the m2 body will be in upwards direction, and the tension acts by the m1 mass, that is T. Here the tension acts by the m2 mass, that is T. Here there is a tension 2T. Now we have to find the acceleration of the entire system by the Newton's laws of motion. How we can find acceleration? Due to the acceleration, we have to find the tension also. Now we have to find acceleration. To find acceleration. So coming to the equation, we can write, we have to observe the body mass m1, then so we need to draw the free body diagram of mass m1. There is a tension T should be acting upwards and the weight should be acts, it is m1g. So it is m1g in downward direction. Here m2g in downward direction, and the acceleration should be acts in downwards. So this is the block. From this we can write that the equation m1g minus T, it is equal m1a. So the basic equation, it is equal mg minus T, it is equal to ma. So mg, it is the weight of the body, and T, it is the tension in a string. Ma, it is the force acting on the body. So this is equation 1. Coming to the second body, so we have to draw. So this is the point, and here this is the tension T, and this is the weight of the body m2g, and this can be acceleration a. So this is the block. From this we can write the equation where T minus m2g, it is equal to m2a. Here the block should be moves in upward direction, then upward force T is greater than to the m2g. That's why you can write T minus m2g, it is equal to m2a. So this is equation 2. From equation 1 and 2 we can write that, where from equation 1 m1g minus, so here m1g minus m1a, it is equal to T. T should be come this side, and from second equation we can write m2a plus m2g, it is equal to T, right? m2a plus m2g is equal to T. So from these equations LHS is equal to RHS, so we can write that whereas m1g minus m1a, it is equal to m2g plus m2a. Now just we simplify all the a terms one side and all the g terms another side. So here m1g minus, whereas m2g, it is equal to m1a plus m2a. And since we can write that where the g will be common here, that is m1 minus m2 is equal to a will be common here, that is m1 plus m2. So now we have to find the value of a. A, it is the acceleration, where acceleration a, it is equal to g into m1 minus m2 by m1 plus m2. So this is the acceleration of this system for an Atwood mission. A is equal to g into m1 minus m2 by m1 plus m2. Hence the acceleration of the system, is equal to system A, it is equal to g into m1 minus m2 by m1 plus m2. Now we need to find the tension in the string. Tension. So by the using of second equation, T minus m2g, it is equal to m2a. So T is equal to m2a plus m2g. So here the value of a is already we derived it, so that is m2 into a, it is nothing but g into m1 minus m2 by m1 plus m2 plus m2g. So here m2g and m2g will be common, so there is m2g, then we can write m1 minus m2 by m1 plus m2 plus there is 1. So here we need to simplify m2g into m1 minus m2, it is LCM, it is m1 plus m2 plus, whereas m1 plus m2. So here the minus m2 and plus m2 will be cancelled out. Here m1 plus m1 2m1, then m2g into 2m1 by m1 plus m2. Here 2 m1 m2 g by m1 plus m2. So here we just write that tension T is equal to 2g into m1 m2 by m1 plus m2. So this is the tension in a string which was acted by two blocks, and we need to find the tension acts at this point 2t. So whereas 2t, it is equal to 2 into t. What is t? That is 2g into m1 m2 by m1 plus m2. So here we can write that this is 4g m1 m2 by m1 plus m2. So this is the tension acts at this point. Here the tension acts at this point, it is equal to m1 2g m1 m2 by m1 plus m2. So this is the tension acts. The acceleration should be here g into m1 minus m2 by m1 plus m2. So this is the Atwood mission to find easily by the acceleration of the system and to the tension in the string. Now let us see, there is an example. Here there is an Atwood mission having the 1 kg block and 3 kg block with Now we have to find the acceleration of the system. Find acceleration of the system and the tension in the string. So here there is a tension acts here T, and here the tension will be acting upwards, and here there is tension 2T, right? So here this is the acceleration in downward direction, and here the acceleration in upwards direction. And acceleration due to gravity G, it is equal 10 meter per second square. So this is the given data. Now we have to find the acceleration of the system, which we had learned earlier. So the acceleration of the system, already we derived it. A is equal to G into m1 minus m2 by m1 plus m2. So this is the standard method we have to refer. So G is equal to, already we know that 10 meter per second square. So here the given data G, it is equal to 10 meter per second square, and m1 it is equal to 1 kg. So let it m1 and let it m2. So m1 it is equal to 3 kg, and m2 it is equal to 1 kg. So then we need to substitute all the terms in acceleration. A is equal to 10 into m1 minus m2, 3 minus 1 by 3 plus 1. So here 10 into 2 by 4, where 2 times of it is 5 times of. So 5 meter per second square. This is the acceleration of the entire system. And now we have to find the tension of a string. So tension T, already we derived it. T, it is equal, whereas 2 into m1 m2 by 2g into m1 m2 by m1 plus m2. This is the tension in a string. So G is equal to, already you know that is 10, where m1 m2, that is 3 into 1 by 3 plus 1. So just we can write that it is 20 into 3 by, whereas 4, right? It is 4 5s are 20, that is 15 newtons. So tension, it is the force, then tension in a string, that is 15 newtons. The tension acts at the this point 2t, then it is 2 into 15, we can write that it is 30 newtons. Here 15 newtons will be acts, here 15 newtons will be acts. The total tension acts here, and net tension, that is 30 newtons. Here the acceleration, it is equal 5 meter per second square, it is in downwards. Here the acceleration, it is 5 meter per second square, it is in upward direction, right? This is the standard method to find by the using formula. In another way we have to find that is, so here there is a Atwood machine having the 3 kg of block and 1 kg of black, and there is tension T acts in this same pattern. So that is acceleration will be drawn in this direction. So for the first body, first block, the weight should be, it is 3g acts in downwards, it is 1g will be acting downwards. Then we need to find the equation for the first body, so that is m1 body. So here free body should be, we can write that is t will be acting upwards, and 3g will be in downwards. This is the block, and acceleration should be in downwards. Then we can write that 3g minus t is equal to 3a. So the basic equation, it is mg minus t is equal to ma. From this we can write that 3g minus t is equal to 3a. So coming to the second body, so that is, so here this is the mass, so there is tension T, and here there is a weight should be 1g. So then the acceleration, it is upwards a. So then we can write that it is T is greater than weight of the body, T minus g, it is equal to a. 1 into a, that is a. So then, so both should be simplified. We can write that t and t should be cancelled out. So then 3g minus g, it is 2g is equal to 4a. 2g is equal to 4a, and g is already mentioned that g is 10 meter per second square. So 20 is equal to 4a, and A it is equal 20 by 4, that is 5 meter per second square. So A it is equal 5 meter per second square, which was already we have proven in first method as per formula. So this is the another method. And coming to the tension, so here we need to use this equation. So then T minus G it is equal to A, then T is equal to G plus A, where G is equal to 10 meter per second square and A is equal to 5, then it is 15 newtons. Tension T is equal to 15 newtons. Already we have to calculate it as 15 newtons. And 2T will be acts at this point, then 2T, 2 into 15, it is equal to 30 newtons. That is 30 newtons. So this is the second method to find the acceleration of the system and the tension in a system.